right. So here's our mnemonic phrase for lateral resolution. Ladder kind of sounds like lateral resolution, right? That's why I always feel like it's easy to remember lateral from axial resolution, because the lateral resolution, the mnemonic phrase kind of sounds like lateral resolution. Okay? Latter is our mnemonic phrase, guys, standing for lateral, angular, transverse, and azimuthal. What we seen azimuthal before? What? That is perpendicular. That's what we were talking about in chapter 6. We were talking about the interaction of sound and media. We were talking about incidence. Okay? Remember, our perpendicular incidence is also known as azimuthal. Okay? 90 degrees.
Oh, so I should have been this already.
Go back to 6 weeks behind.
That wasn't 6 weeks ago.
More than
That
6.
was like a month ago.
Not all.
But didn't I tell you it's a build-up? Didn't I tell you? Don't be hurting, because you know our final is comprehensive. Our final is going to be over the whole semester. It's not just going to be over chapter 12. Chapter 12 and 1 through 11. Comprehensive final. Okay? So again, guys, lateral, angular, transverse, and azimuthal are all different synonyms for lateral resolution. Do it. What are our synonyms for axial resolution?
Synonym for
Axial resolution.
lat. Lat.
You ever used to watch Sonic the Hedgehog? Sonic the Hedgehog, when he stand like this and he tap his foot and he says, "I'm waiting. I'm waiting for my answers, bro. What are my 5 synonyms for?"
Oh, you want the whole thing? Longitudinal, axial, axial, radial, range, radial, and depth.
My man. Don't forget them. Don't forget them. Everybody should know them now. We've repeated them like 6 times. When? What are those again? So when I have those synonyms on the test, don't get confused. Okay? Because I know the synonyms already. Test already made. I'm ready to test today. Who ready? Who ready? I already made the test. I'm ready to go.
Nobody's there.
For this test right here.
For today?
After
Oh,
lectures,
the
okay.
test.
Oh.
I got the quiz. That's ready. The
Okay.
test is ready though.
So we can call axial that it's, since this is transfer, the other one it can be sagittal. Axial resolution because it goes that way, right? It goes.
Axial resolution?
Mm-hmm.
That is.
You have here transfers, right?
Mm-hmm.
So if the other one
Longitudinal.
is
Longitudinal.
parallel like this, right?
Longitudinal.
Yes, longitudinal. Yeah,
Not
this is
sagittal.
long, right?
Sagittal is
Yeah,
describing
it's
a
long,
plane.
yes.
Sagittal is describing a
So,
plane
yeah,
in the
okay.
body. Right? So definitely not sagittal. We just use those terms synonymously in ultrasound when we're labeling our images. Okay? Ladder. That's our mnemonic phrase for lateral resolution. Okay? Lateral, angular, transverse, azimuthal. Okay? Remember, just like transverse waves, they affect particles and that are perpendicular to the sound beam's main axis. Remember, our transverse waves, up and down.
Mm-hmm.
Okay. Lateral resolution. All right, guys. Units are also any unit of distance, preferably millimeters. Okay. Smaller numbers are preferred since they indicate more accurate images. That is true for both axial and lateral resolution, correct? The smaller the number, the better the resolution. Okay. It's determined by, we all know this. Y'all just took a test
Bandwidth.
before even y'all even officially learned
Beam
this.
width. Beam width.
The width of the beam. Okay? Lateral resolution determined by the width of the beam. Is it true that lateral resolution remains the same across the length of the beam? Is that a true statement?
No.
That is a false statement, right? Lateral resolution changes
With the sound beam.
along the length of the beam, right? Because the beam has a focus, right?
Mm-hmm.
So the beam is going to converge first and get to the focus, and then it's going to diverge in the far zone. Okay. So no, lateral resolution changes as the beam travels. Okay. Lateral resolution changes as the beam
So which one
travels.
is better?
We're gonna talk about it. We're coming to it right now. Actually. Okay. So narrower beams have better resolution. Okay. It's gonna be better able to distinguish those structures that are side by side and separate them and identify them as two distinct echoes. Okay. Beam diameter varies with depth. How is beam diameter related to lateral resolution? It's based on what you guys know already.
The smaller and the bigger, right? So it depends.
Directly related.
Yeah.
The wider the beam, the higher the lateral resolution.
Mm-hmm.
We don't like big numbers, right? We like narrow beams to get a narrow numerical value. Okay. Good job, Farnaz. Again, lateral resolution changes with the depth. Changes with the depth. Okay. Questions, guys? Up to this point, definition of lateral resolution. What is our Sophie? What's our mnemonic phrase for lateral resolution? Win, help them out. As a mute. Okay. President. What is lateral resolution determined by? With the what? What is axial resolution determined by?
Spatial position.
There we go. What's it related to, Jasmine? What's axial resolution related to? We know it is determined by the spatial pulse length. What's it related to? No, it's related to the pulse duration. It's related to the pulse duration, right?
The shorter the better.
The shorter the better. All right, guys. Lateral resolution, guys, is best at the focus. Why? Because that's where the beam is the thinnest.
Yeah,
That's where the beam is the narrowest. Okay? So lateral resolution is best at the focus. Okay? At the end of the near zone, right? What's another term? What's the other two terms for the focus? The end of the near zone. How else can I describe the focus?
Focus point. End of the focus.
Focal depth.
Focus point.
Middle of the focal zone. They go two.
End of the near zone. Beginning of the far
You got
zone.
that one. End of the near zone.
And start beginning of far zone.
The beginning of the far zone, guys. The beginning of the far zone. Okay? Those three ways to describe the focus. The end of the near zone, the end of the Fresnel zone, the Fresnel zone, okay? The middle of the focal zone, okay? Or the beginning of the far or Fraunhofer zone.
Fraunhofer zone.
Those are three ways to describe our focus. Okay? Where our lateral resolution is best. Okay? Lateral resolution is good in the focal zone, right? Because that's where the beam is relatively narrow, right? So it's still good in the focal zone, which is what you're changing. Remember I told you guys that a lot of people just go and change their focal zone to the whole screen. But that's not really great for our image quality, okay? It's okay to do that, but I prefer you guys leave the focus the size it's supposed to be and adjust it accordingly, all right?
Does that make the machine work too hard, or?
It's cheating.
It's not cheating because the machine can do it, but it's just you're making the whole area into a focal zone now instead of it being like a small focus. Now the focus is going to be a little bigger than what it originally should be, and we're going to talk about that when we talk about focusing and we talk about electronic focusing, which is what we use. And I'll explain why is it which, because it's about how the electronic signals are sent to the different PZTs.
Yeah, I was thinking like maybe how you didn't want the color box to be open.
Yeah, that makes it work harder.
Yeah.
That makes it work harder.
I thought it was the same.
You can say that, but the machine has those capabilities
Oh, okay.
already built in. But when you open your color box big, it does make the machine work harder.
This could make it sound like when you take a picture and you want to make a blurry background and you want to focus the image, so you want to keep the focus as small as much as possible,
That is
so
true.
you can
I
see the
like
picture
that.
better.
Dude, you on your analogies today, bro. You had some good rest this weekend. Huh? Coming here fully rested, ready to go.
I got my coffee strong today.
I like it. You must have got that Indian coffee.
The time change.
That time change too. I'm
Not
telling you.
only him, even Pat. She was different today.
Laughing a lot.
That time change was a monster. I wonder why I don't know how I still got home at 3 o'clock in the morning on Saturday. I was like, man, how did this happen? That means I had an extra hour. Goodness. I had to stop at my sister's house. I couldn't make it home. Guys, the mathematical relationship that describes lateral resolution is easy money.
Beam
Lateral
diameter.
resolution is equal to the beam diameter. Okay? Lateral resolution is equal to the beam diameter. Alright? Okay, again, lateral resolution. Also, a minute, real quick, I did want to explain this image right here, guys. So, you see, for example, lateral resolution is best at the focus. So you see, even though the two structures at the focus are further apart than the structures in the near zone and these two structures in the far zone, right?
Mm-hmm.
But these structures, because the resolution is better at the focus, these structures right here are still gonna be represented as two distinct structures because the beam is thin enough to separate those, okay? If both of those structures lie within the width of the beam, then they're gonna be represented as one structure, okay? Same thing right here. Both of these structures are within the width of the beam, they're gonna be one structure, okay? I kinda drew that the other day on the board, but that's why resolution is better in the focus, okay? Which is now, like I said, we have phased array transducers, which is, Pat?
Hazel is adjustable transducer.
Adjustable focus or multi-focus okay? Adjustable focus or multi-focus. So it's gonna send multiple beams down the same scan line. So we can put one focus in the near zone, in the middle of our depth, and in the far zone. Okay? So now we have 3 beams creating one image. Okay? And we're gonna have great lateral resolution across the whole entire depth of that beam. Alrighty? Alrighty. Questions, guys, real quick. We have any questions concerning lateral resolution?
So,
Go ahead, dude.
we don't have adjustable and typical value?
I didn't put that on there.
No.
My goodness. We gotta do a little work, dude. I'm sorry I didn't do all the work. No, I'm just playing. So, but it doesn't, in the book, it doesn't have a typical values, right? It doesn't have typical values or adjusted or determined by, but you know you can't, it's not adjustable anyway,
Yeah.
okay? We can adjust ours now with electronic focusing, but from what we learned last chapter, with a single element, continuous wave, unfocused beam, then that beam focus is gonna be fixed. But with multi-focus, yeah, we can change the focus. All right, so that focus will be adjustable in newer transducers. Okay.
They don't have a typical value.
They
Don't
don't.
see the picture. Yeah.
Is there a formula or is it just
Beam diameter is equal to the lateral resolution. Same thing, like a continuous wave. The frequency of a continuous wave transducer is going to be equal to the input power.
Why this is would be seen as two structures? Even
Because
this
the beam
middle
is
one
thin enough to separate those two structures.
Oh, there's one out and there's one in.
Absolutely. The
Yeah.
beam is thin enough to separate those two structures. That's why. If both of those structures lie within the width of the beam, it's going to be represented as one structure. Okay?
Like liver and kidney.
Well, those are more dealing with axial resolution because one is in front
Oh.
of the other, right? This would be concerned like if we're in trans, we're looking at the IVC and aorta. You know, what else can I say about? Those are the two I can say that are most common. Those are
Transverse, yeah,
Everybody
IVC and
can relate
aorta.
to that. Everybody can relate to that. Okay. Okay. So guys, what is resolution again, Samini?
that ability
Yeah,
to
accurate
get
image.
accurate images?
Gotcha. Everybody got that. Resolution, guys. Resolution. Okay? So number one, the ability to distinguish two structures lying close together